friends, welcome to the class of Containerization and Docker Technologies by Study9. I'm your trainer from Study9. Before starting with the course, let me give you a brief introduction of myself. I am an IT enthusiast working for almost 10 years in the field of IT administration, cloud and DevOps technology. I have worked with almost all of the cloud platforms, be it on the private or public cloud, and had worked on multiple PaaS technologies that includes LXC containers, Dockers, OpenShift, Kubernetes, and open source Cloud Foundry. There is quite a big hype on the market about containerization, and today I am going to take you to the brief introduction on this course where we are going to study on the Docker stuffs and the technologies related with it. So let's get started with the Docker. So Docker is the next best thing happening in the cloud IT area. The Docker and the Docker inspired containerization movement is the game changer. Why I am telling so? Because it has resolved one of the costliest aspects of the software, that is the deployment. Docker has come a long way in an incredibly short period of time. Now, I am going to depict one scenario that is live before Docker. Before Docker came along, the development pipeline typically consisted of combinations of various technologies for managing the movement of the software, such as virtual machines, configuration management tools, different package managed systems, and complex web of library dependencies. All these tools need to be managed and maintained by specialist engineers, and most had their own unique ways of being configured. With Docker coming into the picture, the scenario has changed, allowing different engineers involved in this process to effectively speak one language, making work together a breeze. Everything goes through a common pipeline to a single output that can be used on any target. So this is a common pipeline. There is no need to continue maintaining an array of tools configuration as it has been shown in the previous picture. One more important thing to mention, there is no need to throw away your existing software stack if it works for you. When you are Dockerizing your environment, you can package it up in the Docker, and as a bonus, you can see how these containers were built. So if you need to dig into the details, you will be able to do it. Now I will tell you what Docker is all about. To understand what Docker, it is easier to start with a metaphor. After all, metaphor is always better than a technical description. The Docker metaphor is a very powerful one. So Docker is basically a labor who moved commercialized goods into and out of these ships when they docked at ports. There were boxes and items of different shapes and sizes, and experienced dockers were prized for their ability to fit goods into ships by hand in cost-effective ways. As hiring people to move stuff around is not cheap, but it's a matter of fact as that there is no alternative. So this simile should sound familiar to anyone working in the software domain. Much time and intellectual energy is spent getting metamorphically odd-shaped software into different size metamorphical ships full of other odd-shaped softwares, so that they can be sold to customers, I mean the user or the business elsewhere. Now in this figure, we will see how time and money can be saved with the Docker concept. So before Docker, deploying to softwares to different environments required significant efforts. Even if you are not hand-running scripts to provision software on different machines, maybe plenty of people do exactly the same task, which happens here. right? So you have to wrestle with non-configuration management tools that manage state on what are increasingly fast-moving environments, starved of resources. Even when these efforts were encapsulated in VMs, a lot of time was spent managing the deployment of these VMs, waiting for them to boot and managing the overhead of resources use they created. Now, with Docker, the configuration effort is separated from the resource management and the deployment effort is trivial. Running Docker run and the environment image is pulled down and ready to be run, consuming fewer resources and content so that it doesn't interfere with other environments. So we can see a single container with different items being shipped into it, right? So you don't need to worry about whether your container is going to be shipped to a Red Hat machine or an Ubuntu machine or a CentOS VM image. As long it has Docker into it, it will be good to go on any host machine. Now, I hope you got an idea about the Docker concept. So it's formally to define Docker. I know probably you are thinking about installing and coding. But before getting your hands dirty with the code, you should get a grip on these concepts, right? So what is Docker? Precisely speaking, Docker is an open source containerization engine that automates the packaging, shipping, and the deployment of any software applications presented as a lightweight, portable, and self-sufficient containers that will run virtually anywhere. A Docker container is a software built comprising everything necessary to run the software independently. There can be multiple Docker containers in a single machine, and containers are completely isolated from one another as well as from the other host machine. So in a nutshell, the Docker solution let us quickly assemble composite, enterprise scale and business critical applications. For doing this, we can use different and distributed software components. Containers eliminate the friction that comes with shipping the code to distant location. Docker also later stages the code and then deploy it in production as fast as possible. The Docker solution primarily consists of the following components: the Docker engine and the Docker hub. The Docker engine is for enabling the realization of the purpose specifically as well as generic Docker containers. The Docker Hub is a first-going repository of the Docker images that can be combined in different ways for producing publicly redundant, network accessible and widely usable containers. Now, in our next slide, we are going to study some important concepts related with containers. There have been certain ambiguities between containerization and that of the traditional virtualization. Sometimes at a glance, containers appears to be just lightweight form of virtual machines. However, they are different, and here the comparison between the virtual machines and the containers. Virtualization or VMs represents the hardware level virtualization. So you can see this represents the hardware level virtualization, while whereas the containerization represents operating system virtualization, because the containers share resources within the host operating system, which makes them an order of magnitude more efficient. Now, virtual machines, they are heavyweight in nature. That means it will be difficult to start a VM within a fraction of a second. However, containers, they are lightweight resources and they can be started and stopped in a fraction of a second. Applications running in a containers incur little to or no overhead compared to applications running natively on the host OS. So we can see there is a slow provisioning involved with the virtual machines because the file system that is within the virtual machines are quite different. It's not so different, but they have larger amount of files compared to in a containers. Containers contains minimalistic operating system image, which is enough to boot an operating system, or we can say that it is quite enough to launch an application on the on the host operating system. So real-time provisioning and scalability happens in the containers. The lightweight nature of these containers means developers can run dozens of containers at the same time, making it possible to emulate a production-ready distributed system. Now, the engineers can run many more containers on a single host machine than running using a VM alone. So virtual machines, they have limited performance while the containers bear native performance because here the host operating system is being shared by multiple containers. So we will see slowly as we go on in our course how this isolation happens with respect to namespaces, IP addresses, and different other parameters. Virtual machines, they are fully isolated and hence are more secure, while on the containers, process level isolation happen and hence less secure. So next is the diagram between the containers and the VMs. Right. The first figure shows three applications running in three separate VMs. So this is my application stack. So let me just point it. So this is my whole application stack. Similarly, there is another application stack. Right. So this is separate, right? And this is another one. The hypervisor is required to create and run the VMs controlling access to the underlying operating system and hardware as well as interpreting systems call when necessary. So if I say this is my hypervisor, which is basically responsible for spinning up VMs on the host operating systems, and it also caters to different system calls that happens downward to the kernel of the host operating systems. Please bear with my marker representation as it is quite difficult to show in a very flexible manner on the presentation, but I will try to make it more approachable as it can be. Each VM requires a full copy of this host operating system, the application being run, and any supported libraries. So for each VM, it has a guest operating system that in turn communicates with the hypervisor, which makes system calls to the host operating system that uses the compute, storage, and the network resources of the bare metal hardware. In contrast, if we come to our second figure, we'll see three applications that could be run in a containerized system. So similarly, here are my three applications. This is one applications, and these two applications sharing a common library pool running in a containerized system. Unlike VMs, the host kernel is shared with the running containers. That means in my previous diagram I had the hypervisor that was actually allocating resources to the virtual machine upwards. However, in case of containerization, we have a container engine which we also called as the Docker engine, that actually interacts with the host operating systems, and it allocates the shared resources directly from the host operating system without any virtual machine monitor or a virtualized software such as hypervisor. That means my application is directly using the host operating system resources that actually it gets from the hardware level. This means that containers are always constant to running the same kernel as the host. So since it is using the host operating system of the hardware, so the kernel that is there on the host operating system is being shared across three applications, right? Applications Y and Z uses the same library and can share this data rather than having redundant copies. The container engine is responsible for starting and stopping the containers in a similar way to the hypervisor onto a VM. However, processes running inside container, they are equivalent to native processes on the host. So whatever the processes are running inside the host OS, same processes are running inside the containers and do not incur the overheads associated with the hypervisor execution. So unlike a common hypervisor such as KVM or if I say Zen or KMU or ESXi, so it doesn't create separate processes on the virtual machines, right? So the same process that is running on the host operating system used on the application level. It is used by the operating system on the same level. In this tutorial, our goal is to expose the real-world challenges that Docker brings and show how they can be overcome. But first, before that, definitely we are going to provide more through the treatment of Docker basics, right? So now we are going to basically tell you what are the topics that we'll be covering in a Docker training session. So the topics are, we'll be studying what are the differences between containerization and virtualization in more depth, which that we have already discussed in our previous slides. We'll study what is Docker, introduction to Docker. Next is installing the Docker engine and understanding Docker setup. This will be a full hands-on session. Working with the Docker registry. Next, we'll be handling Docker containers. We will see how we can build a container from the Docker image. Next, we'll study about different Docker syntax and the commands. And we'll study on the brief overview of the Docker image management system. That is how the Docker images are stored in the registry and how they are directly being pulled on the host operating system and are being used here. Next, we'll study about Docker files and how to build the custom Docker image. So Docker file is basically it's a file through which we can generate custom built Docker images, right? Next, we'll study about the best practices for writing Docker file, and next we'll study understanding Docker Hub. Then we'll study about Docker networking, and then about understanding services in the containers, and then we'll see how the data can be shared with the containers. Next, we will study on the security part of the containers, and then we will see how we can do orchestration using the containers, and for that we will use the Docker Compose. So Docker Compose is basically it's a technology that we will use, and we'll see how we can basically launch multiple services in the form of containers through a single command. It is basically through a user-defined YAML file that is not being done. So we will go more into it in details. Next, we will see cluster management using the Docker Swarm. and then we will see and we will touch base on debugging the different issues that comes on the containers level. We will then go a little bit deep on the Docker and the DevOps, how they seamlessly work together to bring an complete agile framework in IT landscape. Next, we'll study about, we will have an overview of the microservices, and then we will touch base on the Kubernetes. We will definitely do certain practical use cases on the Dockers. To understand Docker better, we will dive into deploying some applications using custom built Docker image. We will pick custom services like web services, web database, and use it to develop a full-fledged application which is in WordPress. We will create microservice architecture using loosely coupled services like Apache MySQL, as we told about. We will do it using Docker Compose. So with this, we introduced to you about the Docker architecture, and with more deeper technology in our upcoming sessions, we will actually give you the overview, the different kind of functionalities that Docker can actually perform. So in this chapter, we basically learn what Docker is and why it is important and how we can actually start with it. So with this, I am concluding this session for today, and happy coding. Thanks a lot.